So I'm now recording. So if anybody wants to, so just so you all know, and okay, can you all see that?
I think it's loading the presentation mode.
Oh, I don't really know why it does that. It like goes into slide master mode.
That's something new. Master
Yeah.
mode.
Can we all like just look at it from this way? Is that okay?
Yeah, that's perfectly fine.
Okay. Okay.
Yeah, we
Thank
got
you.
2 thumbs up.
Great. All right. Well, welcome everybody. So glad that you joined us today on our Tiny Forest Flood Management training. So today we're going to be talking a little bit about what goes into the flood management. So we'll talk a little bit about tiny forests, how tiny forests help with flood management, what we do, so the methodology that we use to assess flood management, and what kind of data we would be collecting potentially, and what kind of data you would be collecting if you wanted to, and how you would be able to get involved, which is why Divya is here, because she is kind of the contact point for that. And we're also going to look at some of the results and predictions that we've already come up with from our science days this past monitoring season of 2021 to 2022. So I don't really know. I know that Peter, I've met Peter, but I'm not entirely sure if everybody has come to a science day before. But if I'll just go through it quickly anyways, so that we can talk about the monitoring of flood management. But first, we'll just talk quickly a little bit about what tiny forests are. So tiny forests are a dense, fast-growing native woodland, which are around the size of 200 meters square, so the size of a tennis court, more or less. And it's combined with an engagement program to support community ownership and provide social benefits. So the social engagement is kind of the part where we involve you, and we have kind of a citizen science program going on, but we also have people involved in the plantings and knowledge sharing and all sorts of things that have to do with the community. But we also have a scientific approach to the tiny forest, because we want to know what the benefits are for tiny forests, and we want to research them and understand what their ecological benefits are in cities and urban environments. And we want to understand how they work as a nature-based solution, and how they can help to tackle climate change. So we make these forests in accordance with the Miyawaki planting method, which is a long used method that has been produced by a Japanese botanist called Akira Miyawaki from Japan. There are quite a few rules and guidelines that kind of underpin this forest planting technique, but ultimately it's the fact that it's very small and extremely dense. So we want to know how useful they are in cities. So some of our topics that we look at in terms of the research are flood management, carbon storage, so kind of the potential for carbon to be stored, like carbon dioxide, thermal comfort to tackle potentially the urban heating effect. So I think I mentioned all 4 of those: flood management, carbon storage, thermal comfort, and and biodiversity, of course. So we also like to look at the ability for tiny forests to attract biodiversity, and how much more biodiversity it would potentially bring in as opposed to other places. So we want to understand how tiny forests help with flood management. So of course, we are at greater risk of flooding due to the climate crisis, and these kind of places would be very beneficial if they were able to hold in water and retain water, because in comparison to kind of urban landscapes that typically have a lot more cement and roads and things like that, you would have something that would potentially retain quite a lot of water, which is kind of the soil of these tiny forests. Now, they've been prepared in a very specific way, so they are kind of rotivated. So when we have the land that we want to plant our trees into the tiny forest, we typically like excavate the soil and then we add in soil supplements. So we'll typically excavate to 1 meter in depth, and then we add different soil supplements depending on what the needs are, based on what the soil is like already and what the potential trees would be needing from that soil. So this could either be compost, chopped straw, sand, and then on top of that, we add a layer of mulch once the trees have been planted. So as you can imagine, all of this creates quite a really good condition for the soil to really retain quite a lot of water. But on top of that, of course, we have the ability for trees to help with flooding. So you have this kind of rainfall interception that happens because you have kind of the canopy of trees that intercept the water and prevent it really from infiltrating at a much faster rate. It reduces runoff because tree roots help to take in water. Of course, due to the fact that we rotivate and we dig into the soil, this creates a lot more airy soil, and that's able to hold in much more water than a more compacted soil would be able to. So typically, tree roots have an ability to help with water retention by 153% compared to places with no trees. So that's very positive, and that's why we would want to be looking into this more with our citizen scientists and our volunteers. And so we've already done this quite a lot. So here are some examples of some of our science days that we've done over the season. I believe we've completed, I think, just over 60 to 70.
I think we've hit 78. Yeah,
wow.
Close to 80 almost.
78 science days. So here's a kind of a collection of some of the things that we've done. We've involved schools, people from the community. We've had corporate partners as well. And they've all been involved in the soil infiltration and compaction experiments. These have gone really well for us, and yeah, we're going to go into it a little bit more because we're going to introduce you a little bit to what happens, so you have a better understanding. And if you were wanting to do this on your own outside of the science days that we attend, we will give you the necessary tools that you would need to perform this. So I think the best way to do that really is to just go directly to the portal, which is kind of where we have all of our tiny forest sites and where we would find all the information. So I'm just gonna go onto that. Are you still able to see my screen that isn't the PowerPoint presentation?
No, I don't think so. I think
Okay.
it's just the PowerPoint being shared.
Okay. So I believe I'm going to stop sharing.
Yeah. Then you might have to probably share the screen instead of that one window.
Yeah, that's a great idea. So I will share this screen. Yeah. Can you all see that?
Not yet. Oh yeah, now we do.
Okay, perfect. So here I will show you. Oh, don't know why it's not. Sorry. Right, okay, that's not working. Okay, so if we go to tiny forest sites, here you'll be able to locate your closest tiny forest. As of now, we've planted 151, but I believe it's 150 coming up in a couple of days. So as you can see, you can kind of zoom in and out and just look at your preferred area. So for example, I live in Oxford, so I will look at these two tiny forests. So I have one here in Littlemore that's pretty close to where I live. And there's also one in Meadow Lane. So these are all tiny forests that have been planted already and that that anybody would be able to access and visit whenever they wanted to. So if we just go to, let's say Meadow Lane, that's the one I'm closest to. Okay, I don't know why, but I can't type. So here actually is the back end of the data platform. So this is if you were interested in being a citizen scientist, you would be able to go into kind of you'd be able to see all of the tiny forests, kind of the way that they're being shown this way, and you could enter each of their profiles. So let's say I wanted to go into, let's go to Bulwell Park. So here you have a very handy list of different places that will take you to where you need to go. So the ones that we're interested in right now would be to take a survey. And this is typically what you see if you come to our science days, where you will see all the different surveys on a QR code that you scan on your phones. And it will take you to a list of different surveys. Can everybody see the surveys?
Yep.
Perfect. Okay. So the ones we're interested in here today are flood management, infiltration rate and moisture, and flood management, compaction, color, and texture. So if we go to infiltration rate and moisture, this is kind of what the survey would be looking like if you were to fill this in on your phone or your tablet. So it's quite easy because you can just follow through with pictures, and then you click submit. But of course, this comes with our field sheet. So I'll just go back to resources. And here you have loads of different resources. So here you would have your survey guide. So this will tell you exactly what you would need to do step by step. And then you can also see the data sheets. So this is if you really didn't want to enter any data on your telephone or your tablet, you could print out any of these field sheets and fill them out and send it to us, and we could put it onto the portal for you. There are also some great educational resources and videos. So if you ever get stuck reading any of the protocols, you can also look at some of our videos with a step-by-step guide. And so let's just go to our survey guide. So we're going to look at infiltration. So the first thing that while it loads is that if you are interested in doing some of the flood management data collection, we will send you some equipment. Oh, somebody just came. So we will send you some equipment and you'll be able to do this on your own. So it'll tell you exactly what equipment you'll need for each survey. So for example, for this one, it's about flood management, infiltration rate, and moisture. So we're going to look at how water gets soaked into the soil of our tiny forests. And in this case, you would need a water bottle, a measuring jug, a stopwatch, a ruler, and then either your tablet phone or a printed field sheet. Now we would send you all of these things, so you wouldn't need to buy anything if you were so interested. And this is where you kind of locate whether you're going to be doing this in the middle, the edge, or the outer part of the tiny forest. So ideally, it would be good to conduct the survey in all three places. But of course, depending on time, you might also just want to do the inside versus the outside of the tiny forest. just remembering whether it's in the middle or the edge. So then we put in an infiltrometer. So typically we do this on the science days, but if you're doing this on your own, then the infiltrometer will kind of have a sign where it'll say where the bottom is and the line in which you have to knock it into the ground. And we will be giving you a mallet to be able to kind of like knock it into the soil. And then from there, you can start the experiment. So it kind of tells you where about the edge and the outside of the forest and the middle of the forest is. It's kind of like a Miyawaki method. So this is part of the classification of the parts of the forest, but it's very clear here, as you can see. So that you would be recording this. And then, so once you have your infiltrometer, you fill up your water bottle before going to the tiny forest, and you pour it into the jug, and it's about 500 milliliters. Well, it is 500 milliliters. And that's kind of what you're going to be doing. You're going to be putting in the water into the infiltrometer. So measuring 500 milliliters and putting it into the infiltrometer. But before that, we want to kind of see what the soil is like before. So it will ask you in the, once you're doing the survey online, it will ask you what the dryness is of the soil. So you start from 0 to like where there's really no moisture to wet. So this is kind of like you touch the ground, it's properly wet, and you would need to shake your boots before you go inside to saturate it. So this is kind of, you know, it's a bit of a pond-like situation, and then you just have runoff where it's completely saturated, and you wouldn't be wanting to step in there at all. So this is giving us an indication of what the soil is like beforehand, so that we kind of have an idea of what the results mean. And I'll tell you a little bit more about that. So this is a much clearer image. So you would be measuring water into the jug and then pouring it into this infiltrometer that's already been put into the ground. And with the timer, once you've poured all the water into the infiltrometer, you start the timer. And once the water has kind of all seeped through and you don't see any more kind of puddles of water, that's when you would stop the timer. And as you can see, this is being poured in. And this is kind of giving you an indication of how quickly the water is being infiltrated into the ground, how quickly it's going into the soil. So it's a really nice experiment to do for yourself as well if you compare it to the middle and the outside of the tiny forest, because you would hope to see that it would take a lot less time for the water to fully soak through inside of the tiny forest versus outside of the tiny forest, because of what we mentioned, where the soil has kind of been manipulated and it has a lot of air in it, and all these roots because of the trees in the tiny forest. So that's something that you can see firsthand for yourself. And it's a really good indication, because it kind of tells us that if it were to get really wet and start raining and things like that, then how good is this forest at holding in the water? This is kind of really important information that tells us what kind of environmental impacts of climate change that a tiny forest could help with, we could benefit from. So this is the infiltration test. It's quite easy. The only thing really is that if you were to be sitting there with your timer and it's taking a long time, we typically say that after 10 minutes, if you've been waiting there for 10 minutes, which usually you wouldn't be, hopefully not. But if so, then in the survey, you also have the ability to put in 10 minutes, and then it will pop up with a new field in which you would measure the level of the water. So this is why we have a ruler. You kind of put it into the infiltrometer, and then you just read the level of the water to see where it's been left at, because all of it would not have gone in after 10 minutes. So you would just put in that measurement. So that's it, really. So this is our first experiment, and it's a really nice experiment to do. I typically find that children especially really enjoy doing this. They like pouring in the water, And it's a nice thing to see because then we can kind of see for ourselves right away what the tiny forest would be able to do in terms of holding in water. And it's fairly simple. So if you ever wanted to get involved with this, then that's great. We also have another one for flood management, which is a little bit more intricate, I guess. Mostly just because you would be involving your hands in this. So if nobody's ever done this before, it's very nice. So as part of the tiny forest monitoring, and when we're looking at flood management, we also want to be looking at the role of the soil. So how the soil feels and what color it is and how compact it is. So we would be, this kind of gives us an indication of how good the soil is for our trees, and also what kind of soil that we're dealing with, because some soil is better for flooding whilst other types of soil are not. So a type of soil that would not be super beneficial for flooding would be a very clay rich soil, because that would be like not as porous as a soil that had maybe a little bit more sand mixed into it. So this is all something that we as citizen scientists can look at and can already tell. And so we can look at this. We also look at soil compaction. So that's another thing that we would be giving potentially to you, which would be something that measures compaction. It's called a penetrometer, and it's very easy to use, and we can go through it right now. So again, here are some of the things that you would need for this particular survey for soil compaction, texture, and color: a penetrometer, a flow diagram for soil texture, which is part of this protocol. So you would just have to print it off or have it on your telephone somewhere. A soil color chart, which is also part of this protocol. A pair of gloves is optional, but it's always beneficial to be using really just like your fingertips to be able to tell what the texture is. And it's also very healthy to be put in, to be around the soil. It helps with our gut microbiota. And of course, somewhere to record all your data. So your telephone, a tablet, or a printed field sheet. So again, these are some of the instructions. I didn't mention this earlier, but this can be done pretty much any time of the day, any part of the year, whether there's heavy rain, snow. In fact, it would be really interesting to know what it would look like before and after like a very rainy or a major like rain event. So kind of seeing how good the soil is at holding in water and what kind of soil color and texture it would be before a heavy major rain event and after that. So first we again choose a spot. So we can either be in the middle of the forest, the edge of the forest, or outside of the forest. Usually on a science day, we want to do all three with at least 2 data points of those 3 places, but of course one of each is also fine, and it doesn't take very long. Again, here are the classifications of what counts as the middle and the edge and the outside. So the middle basically is anything that is, well, I'll start with the edge. Anything that is within 2 meters of any kind of fencing. So if you find a spot where you have a fence or a classroom, so this is kind of like a place with benches that you will see typically in a tiny forest, anything within those 2 meters is considered an edge. Anything beyond that is the middle. So the first thing is the compaction of the soil. So you have really nice diagrams here that will tell you exactly how to use this penetrometer. It's a purely mechanical device. It's just a small little pen sort of thing that you press into the soil, and you only have to press it up to a point where there's a little groove. So you'll see a small groove at the top of the penetrometer right here, and you press that into the ground, and you only press it until that groove is covered. So typically when you have like very, very loose soil, like the kind of soil that's very spongy, you really don't need to press in that much. Sometimes it'll barely even move what is the kind of rubber over here that is going to give us our measurement. So the more we press, the more this rubber kind of moves towards a number, and then the higher the number, then the higher the compaction. So as you can see, for example, here you have 1 is a low compaction, and then the higher you go up to 4.5, the more compact your soil would be. So if that makes sense, kind of the harder you press, the more compact your soil is, which would make sense because compaction is a level of how packed the soil is or how like close together it is. So that's really just all you have to do for compaction. You would push it down, flip it around, and then look at the top of your band to see what number it is. Just keeping in mind that this isn't, for example, this is not 40, this would be 4.0. I'm not sure you can see it, but paying close attention to that. And then the next step is the really fun part, which is the soil texture. So it's kind of taking a ball of soil in your hand and adding some water to it. Remember, we've filled up our water bottles prior to going into the tiny forest, so we have some water to be able to use for this. And we can roll it into a ball, and we follow this lovely diagram. So this diagram is pretty much what scientists will use to determine soil texture. It's really robust, and we've used it quite a lot within Earthwatch in other projects as well. So so you have a handful of soil, and basically you want to make sure that you're able to roll it into a ball. That is the first thing. So if you can roll it into a ball, then you proceed to the next questions. If you cannot, however, that's typically a type of soil that is sand. So sand, the kind of sand that you see on the beach, for example, if you see kind of trees in an area where there's beach, that soil will be sand typically. And there will be certain trees that are highly adapted to being in sand, whilst other trees don't like that very much. So if it's not sand, then what do? You would place it between your finger and your thumb and squeeze it upwards to make a ribbon. So you're just kind of basically squeezing it in this kind of motion. I don't know if you can see what I'm doing. But yeah, you'd be doing that.
Yep.
Yeah, can you see that? Cool. And if you can't make it into a ribbon, then it's another type of sand called loamy sand. However, if you can, then you go further, and then basically it'll just ask you, so the length of your ribbon, sorry. So how long is your ribbon? This is kind of like a small size ribbon. This would be a medium size ribbon, and this would be a long ribbon. So you can imagine if it's a very long ribbon, that's typically because it's made of clay. So all of these types of soil would be clay. So you have sandy clay, silt clay, and clay. That's just because if you think about the way that you would use kind of Play-Doh, it's very moldable. So that's the kind of soil that you would have if you were having really long ribbons coming off of your hand. Then you have kind of medium ribbons that are more a mix. So you'd have sandy clay loam, silty clay loam. And the smaller ones would be sandy loam, silt loam, or loam. So loam is also a type of soil. And whichever one you come to, so the next question would be, how gritty does it feel? Is it very gritty, or is it very smooth, or is it neither? Like it's both, basically. You don't really feel it's super gritty or super smooth. It's just kind of both. And then you come up with your soil texture based on what you felt and what you have decided. And you can have somebody else do that and kind of see if it's similar for them. Come to a consensus, and then you would put that in as your soil texture. So let's say your soil texture was sand, then you would put in the soil texture as sand. So this is all happening in the same place. You've done your compaction, you've moved on, and you've taken your ball of soil, and you've played around with it until you figured out what the soil texture was. And then in the same area, you're also going to look at with a piece of dry soil, you would look at what the color was. So these are all different colors that soil can be. And typically what we do is just kind of hover it over these colors until we can see the most appropriate color that our soil looks like. And each of these colors has a code. So you would go, for example, if this is my color, I would go, that's G4. So that's basically my color code. Based on the color chart. So you would put that in, it'll ask you what the letter is and what the number is. And then you're done. So basically you've done compaction, texture, and color. So this will kind of, you can see if this changes in the middle of your forest. Even within your tiny forest, sometimes the compaction and the color and the texture will change. Typically, we will go in with all these soil supplements that I'd mentioned previously, but the original site might be a mix of different things. If, for example, it was an old construction site, it might have a lot more sand in some areas. You know, if you're in places that are closer to the beach as well, if you I guess it just depends on the area. Every area in the UK has like a predominance of different types of soil. Some forests will have more clay-like soil, some forests will be more loamy, and each tree will have its own necessary kind of preferences of soil. So that's it. So that's pretty much what we would do for flood management. We looked at infiltration, and then we looked at soil compaction, texture, and color. So that's great. I'm going to move you to then back to the PowerPoint presentation, if I can figure out how to do that. I can. Yeah. Okay. Can everybody see?
Yes,
Yeah,
we can.
great. Perfect. So that's pretty much coming towards the end. Oh, no, sorry, that's not true. I'm first going to go through this. So here are some examples of what kind of things we would be doing on our science team to see what flood management data would look like. So this is based off of all the lovely flood management surveys that we've gotten over the season from schools, from people coming in and volunteering and doing these soil surveys and these flood management surveys. And as you can see, this is the first thing. It's basically the amount of time that it takes for the water to soak through into the soil. And then you have the comparison of edge, middle, and outside. So as you can see, the outside takes more time. So it would take about 125 seconds, for example, maybe 130 seconds on average, compared to the middle and the edge of the forest, which are the inside of the tiny forest. So that's basically where you would find your trees. So as you can see, there's quite a difference. Specifically, why the middle would take more time than the edge, we're not sure. We're still investigating. But this is the kind of data, for example, that we would look at, and this would kind of give us an indication of, well, just how well water flows in our tiny forest. Also, the soil compaction has been looked at. So we look at how compact the soil is. If you remember on the penetrometer, the higher the number, the more compact the soil is. So as you can see on the outside of the tiny forest, so the parts that haven't had trees or any of the soil like manipulated in them, the soil compaction is almost, yeah, maybe like 2.5 times as high. So that's quite a dramatic amount. So it would be a lot more difficult for other trees to take roots outside of the tiny forest on like grassy areas or park areas than it would inside of the tiny forest. So this is just an example of what we would be able to do with all of your data. If you sent it to us, if you put it onto the portal. So that's naturally what we would get to. So how you could get involved. So you could find your local tiny forest as a first step. We have 149, almost coming to 150, and we'll be planting a few more. And you could do these flood management surveys at any point once we've planted the tiny forest, of course. Please express your interest to us. Tell us whether you are already a tree keeper or you're looking to be one, whether you just want to do this because you want to do it, or you have a particular group of people that you want to engage in mind. There's loads of different ways that you could engage with the tiny forest. Of course, the flood management way is one of the surveys that we could potentially do, but there are loads of other surveys that some of them don't even require any equipment. So a lot of our biodiversity surveys, like counting any butterflies or pollinators, is a way to get involved and not use any equipment if you didn't want to. You would be able to access the portal. You could either not have to access the back end of the portal. I don't know if you remember seeing all the list of tiny forests that I could see. You could also just ask for a QR code of your own tiny forest, and we could send you that. And you could just go onto there and look at all the list of resources that you would need. So your field survey protocol, your protocol, so what we just looked at with all the pictures, and also a field sheet. So this is if you didn't want to put the information onto your phone or laptop, this could just be written down and you could take a picture and send it to us. And of course, if you're interested and you've located your tiny forest and you decide that you wanted to, that you've spoken to Divya or somebody else on the team, maybe Georgina as well, who is involved with this, you could receive a monitoring kit, or there might even be a monitoring kit very close to you. So finding out how maybe that could be exchanged with other people or anyways, there's always a way to get involved, and we can talk a little bit more about it later on. I don't know what everybody's individual situation is like, so of course I think it's important that we talk about that a little bit and just ask you where your interests lie. But you can always contact us through our email, so tinyforest@earthwatch.org.uk. And yeah, please join us and be part of our citizen science program. And I'm going to stop sharing right now so that if anyone has any questions or any comments or wants to say anything, they won't be a part of this screen recording. But thank you all so much for joining. Okay, so I've stopped the screen recording if anybody wants to.
It still says recording.
Does it?
Interesting.
Oh,